要开始我们今天最后的 keynote 了，让我们以最热烈的掌声欢迎 Patterson， 然后为我们带来的是 request and response. Okay, let's give a round of applause for Aaron for the last keynote.
Yes, thank you. Okay. Hello, everyone. Hello, hello. Okay, hold on 1 second. I gotta do one thing.
来，那请大家举起你的双手，我们接下来照张很大合照。大家热情一点，让我们全世界都看到台湾的热情。OK?
Yes. Thank you. I have to prove to my wife that I was actually here. Okay. And then put this into airplane mode so that when people tweet at me, it won't make tons of noise up here. I'm sorry. Yeah. Okay. All right, let's start. Oh, I guess we already started. Let's get started then. Hold on, I gotta cue this up here. All right, well, welcome to my webinar. Thank you. Thank you for joining me here. Thank you for coming to RubyConf Taiwan. Thank you so much for having me. I'm really honored to be here. Thank you to the organizers. Thank you for all of you for waiting throughout the entire conference just to see me here today, so I appreciate it. Thank you so much. Hi. My name is Patterson. I'm on the internet as Tender Love. I work for a very small startup company that's from North Carolina in the United States. I'm not sure you've heard of my company. I work for Red Hat. Very small startup company. The team that I'm on at Red Hat, I work on the Manage IQ team. This is the team that I'm on. We build a product to manage clouds. So if you have a cloud, we can manage it. Since you all have clouds, right? I have one at home. Anyway, our product is open source, so if you want to actually check out the code or run it at work or whatever, you can go check it out here on GitHub. We do all of our development work there. So if you want to try it out, go for it. Also, I'm a pro Neko Atsume player. I've gone pro. This is my yard. I have 2 real cats. I should have put that in the slides, but I have 2 actual cats. This is the first one. Her name is SeaTac Airport, Facebook, YouTube, Instagram. I couldn't fit Instagram on there, so it's just, I cut it off at the end. We're trying to name her after all of the different social networks. This is another picture of her. I actually tried to dress her up as Donald Trump. I don't know if you saw this on the internet, but people were trumping their cats, so this is one of the, yeah, put the, sorry. This is my other cat. He's a bit more famous. His name is Gorbachev Puff Puff Thunderhorse. And I've got stickers of him here today, so if you want a sticker of my cat, come say hello to me and I'll give you a sticker of him. A lot of people ask me though, like, why, how come you only have stickers of one cat? And this, I hope my wife isn't watching this. So people ask, why do you only have stickers of one cat? And the reason is because my wife designs all the stickers and she doesn't like the other cat. So we just have the one. Anyway, I'm on the Ruby core team, the Rails core team, and the Rack core team. I think there's only one person on the Rack core team, I think. I think that's me. And normally I wouldn't mention all of this, except that it's important to the talk today, so you'll see why later. Many developers today are full stack developers, but I'm actually a short stack developer. So I can't do the whole stack. I only do just a little bit of it. And I noticed that I really, really like this venue. I think it's really awesome, especially with all these microphones and stuff. I feel like I'm in a UN meeting. Like everybody should have little name tags in front of them. And I was reading like the little plaque up there, and I just want all of you to go ahead and vote for me now. So you should see in front of you there's 3 buttons. I can't read Chinese, but I'm pretty sure that says my name. So vote for me there. So I got picked up at the airport by Juanito. And I love this sign because he was holding that. He's holding that at the airport, and there's tons of people waiting at the airport, and it says Dr. Tenderlove on it. I can't imagine. He was like, yeah, there was people staring at me with this sign. I'm so sorry. Anyway, so he's giving me a ride to the hotel, and he says, you know, I watch all of your talks on Confreaks, and I notice that you always do 8 minutes of comedy. You always do 8 minutes of comedy, but sometimes you do 12. So you do 8 or you do 12. So I'm going to try to do at least 8 minutes of comedy today. I think I've started already. I heard some laughs, so we'll continue on here. Anyway, you said on the sign I'm Dr. Tenderlove, but I have to tell you a secret, especially since we're in this place of a research institute, facility for higher learning. I am in fact a true thought leader. This is true. I recently graduated from an online university with my degree in thought leading. But this is the secret, is that I'm not actually a doctor. So please don't tell anybody that, because I don't want to get kicked out of this place before my talk is over. So just, don't tell anyone this, please. I have one thought leading pro tip for all of you. If you're going to make slides or do any sort of thought leadering, is to use the Baskerville font. That's what I'm using in these slides. This is very, very important, and the reason that you want to use Baskerville is because it's been proven to be more believable than other fonts. So if you go check out this link down here, I know it's kind of long, just Google for Baskerville believable, this link will come up, and it's really true. It's more believable than other fonts. So anyway, all of my slides today will be in Baskerville, so hopefully you'll believe the things that I have to say. Anyway, so 8 minutes of comedy. All right, 8 minutes of comedy. Let's see if we can do this. So we're here at RubyConf Taiwan, which I noticed a lot of people were pointing out here. RubyConf Taiwan, FTW is at the end there. We have that FTW, which stands for the win, of course, right? It's for the win. I've seen everybody point this out, and what I thought was really awesome is that on the first day I watched a talk about how to win at poker. So I was learning about all these different strategies for how to win at poker, and then I thought to myself, wow, this conference literally is for the win. We're learning how to win at poker. So that was really exciting to me. Then today, I'm so sorry. I watched a talk by Ted. This is my very first TED Talk. I'm so sorry. Where are you? Are you here? I had to do it. Yes, please. Thank you. And then I watched Laurent, and I saw his jokes, and I really, really appreciate it. Actually, we were having lunch together yesterday, and we were talking about the different, puns we were making in our slides, and he's like, "Oh, I made a great one about." I'm using simplified English, and I was like, oh, man, I did exactly the same thing in my slides. So, I said to him, he was like, oh, no, I'll take it out of my slides. And I said, no, don't do that, don't, you came up with this one as well, don't worry about it, so I'm just going to leave it in mine. I'll leave it in mine and credit you. So, like I said, I heard there's simplified Chinese, but in this talk, I'm going to be using simplified English. So, this was all Laurent before me, but I decided to steal some other stuff from his talk as well. So I added a graph. You can see here that it shows numbers. and those numbers are generally increasing, which is good, right? So we've noticed a trend here. They are going up, and some are larger than others. So obviously we want the larger ones more than the smaller ones, but they're all generally going up, so things are doing better. And also you can download RubyMotion here. So I just enjoy this comic. It made me think of that. Anyway, so many of you here today, I including, I'm a polyglot programmer. I program in many different languages, not just Ruby. I mean, I love Ruby. I program in Ruby every day, but it's not my only language. And I noticed at this conference, and especially in the Ruby world, that many people are using, like this is very popular today, is to use plain old Ruby objects. But I don't only program Ruby, I program in other object-oriented languages and some functional languages as well. So it's important to me that I only use plain old objects or poos. Sorry. All right, on to the next minute of our 8 minutes of comedy. So we're here in Taiwan, and I think most people, if you ask them to find Taiwan on a map, they can do it. Like this is right here. If we zoom in, you can see right there, boom, Taiwan, right there. So it's really easy to find on the map, no problems, right? But my question was, where is Tai 2? Okay, next minute of our 8 minutes. So I heard that Netflix is coming to Taiwan. This is true, right? Netflix is coming. So all of you will now have an alternative to Action Cable. We heard some talks about lean development, and I wanted to show you a graph. Like recently, I've been dieting and exercising and trying to lose a lot of weight, and you can see here that I'm losing a lot of weight. I'm not sure quite yet, but I believe I'm a lean developer now. Maybe there's just a few more kilos to go. I want you to notice, I got to point this out here, localization right there, boom, kilos. I just got to point that out. I am from the United States, and we do not use kilos in the United States. So, just yes, yes. So I said I'm from the United States, right? We don't use the metric system in the United States, which is kind of weird. But we do have to measure laughs. So when people are laughing, the way that you measure laughs is actually in key LOLs. Okay, I think that will conclude our 8 minutes of comedy on that terrible one. So I'm going to talk about request and response today. This is the title of my talk, request and response. And this is a very technical talk, and I apologize for that because this is the last talk of the conference, and I know all of you are dying to get out of here, right? I'm so sorry. I'm sorry. It's going to be technical, but let's do it. We can make it through together. I'm going to talk about HTTP2, and I'm going to say H2 from now on because HTTP2 is very long to say. It's difficult to say. And I'm also going to talk about RAC, the Rails request and response lifecycle, and Rails and RAC plus HTTP2 or H2. The goal of this presentation is basically going to look at Rails, RAC, and H2 and how we'll get H2 support into Rails eventually. So I want to start off by looking at H2, but I want to look at it from an app developer's perspective. So I work on apps at work, or I work on Rails, I help work on apps, and I want to look at H2 from an app developer's perspective. I don't really necessarily care about the spec. I mean, the spec exists, like, we need to follow it or whatever, but, I mean, a day-to-day app developer doesn't need to know all the ins and outs of the spec, so I want to look at it from an app developer's perspective. So, some of the benefits are, benefits to the H2 protocol are that it's binary, and this is not always a benefit, I had to put a little asterisk there. This is a benefit. It's a benefit because we're transferring less data over the wire. We can transfer stuff faster. It's easier to compress. But it's not necessarily a benefit because we can't just look at the transfer over the wire and know exactly what's going on. Right? With HTTP1, we can look at, we can snoop the network and see exactly what was happening with our requests. We can't easily do that with H2. But it is easier to parse, which means it's faster. It's faster on the server side, the client and server side, so we can easily generate messages and parse those messages. Another benefit is that it's multiplexed. So H2 is multiplexed, and what that means is that we're going to be doing all of our work over the same socket. So we're going to be using one socket to do all of our transfers. So if you look at normal H1 today, you'll see something that looks like this. Our client's going to make many requests or many connections to the server. You'll notice this when you're downloading a lot of assets in parallel. The browser will make many connections to the server. In an H2 world, it'll look more like this. We'll just have one essentially fat pipe to the server. And the way that we accomplish this is through multiplexing. And what that multiplexing is just a fancy term meaning that we're going to do multiple requests and responses over one socket, over one connection, right? Rather than doing many connections, we'll do all those requests over one connection. So we only have to bring up one connection and we do all of our requests and responses there. Another nice thing about H2 is that it has header compression support. So that means we take all those HTTP headers and just compress them down. And this is baked into the protocol, so we can actually save a lot of data by compressing those headers. Another nice thing about H2 is that it uses SSL. So all of our transfers are encrypted. Now, it doesn't have to use SSL. The original specs, like H2 came from Speedy, which came from Google, and in the original specs they said we had to use SSL. But before the spec was ratified, that was actually pulled out. So the final H2 spec does not require that you use SSL. But the caveat is that all browsers that support it today, Chrome and Firefox, only do it over SSL. So while it's possible to do it over a non-encrypted connection, browsers only support it on encrypted connections today. Now the main thing that is really exciting is server push, and what this is the server can actually say, hey, I want you to take this thing and cache it. It can proactively send things down to the client. So for example, you have a website that has a lot of assets. You know that the client is going to be requesting all of those assets, so you can actually send those assets to the client in advance. You can say, hey, here's all of my really awesome animated GIFs, cache those, and then when it's time to display those GIFs, rather than requesting them from the server, you already have them cached. Another interesting thing, and I don't actually know how to use this yet, is we were talking about pushing assets back to the client. Those are all 200 responses, so we'd say 200 success. You can actually push other stuff down. You can push 3 or 4 redirects if you want as well. The browser will actually cache those. I'm not sure how to use that yet, whether or not it is useful, but you can. So I want to look at how to tell if you're using H2, because this is actually a hurdle for me as a web developer. I mean, I already know I know how to get around in all the debugging tools in the browsers, but how do you actually know that you're using H2? What are the signs? What are the signs that you're using this? And the best way to do it in Chrome is if you go to this URL, and I'll post these slides online so you don't need to write it down. Go to this URL, it'll show you all the connections that Chrome is making. So this is an example here. This is from my browser. You can see I've got only one connection. I just opened this in private mode. Normally, if you go to this URL in your Chrome outside of private mode, you'll see tons of connections. So I've got one connection open, and you can see the protocol negotiated is H2. So there is one way to tell that you're using H2 protocol there. So we're on localhost 3000. And the protocol is H2, so that's one way to tell that we're using it. And you'll see there's a bunch of other data here. You can see how many frames were sent back and forth, and these things are specific to these numbers. It'll show you the amount of data that's transferred, but some of these numbers are specific to the H2 protocol, like the send window and frames. When they're referring to frames, those are H2 frames, but you don't necessarily need to know that. Probably the most important thing is the amount of data that's been transferred. Now, one thing I want you to notice is that if you look at my browser, you'll see that I've got, 5 tabs open. So there's a bunch of different tabs up there. Look at those tabs. Ooh, tabs. Wow. I love using Keynote transitions. They're the best. So I've got a bunch of tabs open, but what's interesting is that you'll notice back on that connections tab, there's only one connection being used. So the browser's actually smart enough to say like, oh, hey, this person has 5 tabs open all to the same web server, but we're only going to use that one particular connection for all of those. Right? Even though we've got multiple tabs open to the same server, we're just going to use that one particular connection. So I think that's a really cool feature of H2. So it should drastically reduce the number of connections that will be open from the client to your servers. Now, the other interesting thing is you can see here, if you open up Chrome Inspector, you can add an extra column there. So you can add the protocol column. If you right-click there, you can say Add a new column. And I just checked the protocol column, and you'll see there that all of those are H2 protocols. And I don't want to, like, so please, at the end, near the end of this presentation, I'm going to say, wow, we're using H2 with Rails. I want you to be really excited at that point, but if you look at these slides, we're already doing it now. So I made all of these screenshots using Rails with H2 with Rails, so please, like, be excited for me. It was a lot of work. All right, so another interesting thing that I'm very happy about is that H2 actually standardizes on lowercase headers. So all the headers, the header keys are all lowercase, which is great. We don't have to wonder, like, is content type, is it uppercase C, lowercase t, or if it's 2 words, what are the uppercase or lowercase that? No, they're all lowercase, all of them. And there are special headers, so there's special headers for the response codes as well as the methods. So if you go down here under the request headers, you'll see that colon method, say like colon authority, colon method, colon path. Those ones are all special headers, and all the special headers start with a colon. So you can see, you can differentiate between normal methods or normal headers and these special headers because the special ones start with a colon. Now, if we compare this to Firefox, I'm not going to spend a lot of time on Firefox because I typically do my dev work on Chrome. But you can tell in Firefox that you're using H2 in a couple ways. Up at the top, you'll see the version. It says HTTP2. And then lower in the response headers, you'll see one that says Firefox Speedy H2. What's interesting and kind of annoying is that, so that's a list of response headers, right? And those top ones, like the cache control, content length, all those, I sent those. So I sent those from Rails, but that Firefox Speedy, I did not send that. But Firefox is displaying that in the response headers, which is kind of annoying to me because I was looking at this and I'm like, did I send that? I don't think I sent that. And I started digging through my code. No, I didn't send that. That's really weird. Anyway, so you didn't send that. It's okay. It's okay, really. All right, so now we've looked at using H2 from the browser side. Next, I want to take a look at Rack. I think there's other people on the Rack core team, but I am the main person, I suppose. And if you want to be on the Rack core team, you should just let me know, because I'll basically just add anybody. See, the problem with, you know, a lot of people are like, oh, I'd love to get involved and be on such and such core team. The thing is, though, you don't realize that it's actually a curse. You'll have to do a lot of work, and then it becomes unfun. So, if you want to be on the core team, I will let you. But if you want to quit, that's a different story. Anyway, so let's take a look at the Rack API. We're going to look at the Rack API as it exists today, what I would like it to be in the future. We're going to look at how it works today, the downsides to it, and we're going to compare it to some other things as well. Note. So yeah, so this is what the Rack API looks like today. You just have an object that responds to call, and that call method takes an environment. That end thing is a hash, and that hash contains a bunch of junk. What is in that hash? Literally, it's a bunch of junk. It's just stuff that the web server stuffs in there, and there's some long spec about the different keys that'll be in there, but it's really just a hash of junk. You can inspect the hash and take a look to see what's inside, but if you look in the rack repo today, there should be a file named spec. If you read through that, you can figure out what all the keys are. Anyway, you can get most of your request info from that env hash. If any of you did CGI programming back in the day, this is very similar to just looking at the end environment variable. Now, the way that you respond is you return an array, and the array looks like this. So this response is a 200 response, and it has xfoo headers, and the body has to be something that you can iterate over. So this body is just going to print out baz. It's just one string, right? Now, this is kind of nice. I mean, it's an easy API. You just get a hash and you return an array, and that's all you have to do. And it works. I think that this API works. People use it, clearly. And I think it's a successful API. And the reason I think this API is successful is because it's easy. It's very easy to do. You can implement any type of server with this. You can really write easy stuff. Now, this is very handy, but I don't think this is the main reason that Rack is so successful. And I want to explain the main reason I think Rack is successful, and it may not be obvious, is Rack solves this problem, an explosion of dependencies. And you probably haven't noticed this, and it's good. It's good that you haven't noticed this. It solves an explosion of dependencies via the adapter pattern. So the way this works is we have a graph that looks similar to this today. You can choose any web server you want to, Unicorn, Passenger, Puma, Webrick, all those things. All those things speak Rack, right? And then Rack goes to Rails or goes to Sinatra or whatever web framework you want to choose, or you can write directly to Rack yourself. So we have on the right-hand side our web framework. So the web servers speak to Rack, and all of the web frameworks speak to Rack, and we have this one place in the middle where we meet. Now, what I'm talking about with an explosion of dependencies is, let's imagine a world where we didn't have Rack, we didn't have this centralized place to meet. What would happen? Well, if we didn't have that one central API, we would end up having gems for every possible combination of web server and web framework. So we'd probably end up with something that looks like this. We'd have to have a Unicorn Rails gem, a Passenger Rails gem, a Puma Rails gem, Webrick Rails gem, etc., etc., etc. Every possible combination. This is the explosion of dependencies that I'm talking about. This is the thing that Rack solves, and I think it's one of the best things about Rack that there is today. Now, the next thing I want to look at is let's compare Node.js and Rack for a second. So I imagine there are many people in the audience that have tried out Node.js before. I have also tried out Node.js, but don't tell anybody that. It's a secret. So I just want to show them for a minute to compare how they work, and we're going to revisit this a little bit later. So at the top is a Node.js example. It takes a request and a response object, and you'll notice that the way that you respond in a Node.js app is you actually call methods on the response. You say, okay, write out the header with the status and these particular headers, and then write out the response body. So in Node.js, we actually stream stuff to the client. This is actually built in. This is built into the framework. Compared to Rack, where we actually have to return a value, which means that we actually had to build up that body in advance. We're not streaming it out to the client. We have to say, okay, I'm going to get together all the stuff and then return it back up the stack. Okay? So I'm going to explore this a little bit deeper, or more deeply later, but I just want you to keep this in mind. So I want to take a look at Rack middleware, how Rack middleware works, and you might be saying, what is Rack middleware? Well, I will tell you what Rack middleware is. It is all those freaking frames when I do puts call stack in my controller. Sorry, I had to get my rage out a little bit. This is my daily life. I'm looking at Rails and how we can improve controllers and stuff, so I take a look at a lot of the stuff that builds it, and I see a ton of these stack frames. So, how does the middleware work? How does middleware with Rack work? Now, we saw the Rack API. This is it. Middleware with Rack, the way the middleware with Rack works is essentially we have a very large linked list. So this is an example of a middleware. We have one middleware here, and all it does is it holds a reference to the next application. Now, when a request comes in, Rack called, or the web server calls call, and our middleware says, okay, I'm going to do some stuff, then I'm going to call the next application, and then I'm going to do some stuff after the next application returns, and then I'm going to return the response back up the stack. right? So we have this very large linked list, and we just go down the stack and then pop all the way back up the stack. So this is what it looks like. Now, what I want to do next is I want to look at all of the middleware in the Rails stack. Okay, we're going to start off with an app with one resource, and the resource is posts. And let me make sure, is my sound on? No. All right, whatever. All right, so we have one resource with posts, and we're going to do a get users. Okay. Now we're going to go. I know it's, what is it? It's 5:22, and it's the last day of the conference, the last talk. We're going to look at every single middleware in Rails, all of them. So I hope you're excited. All right, so the web server parses, the very first thing is the web server parses the request. So the browser sends its data to the web server parses all of that, and then it sends it off to the first thing in the stack. And the very first thing in the stack is Rails application, okay? It's an instance of Rails application, but actually what it is an instance of your app. You'll never see a Rails application in the stack because your application inherits from Rails application. So these two methods are actually implemented on your application. And I'm just including the two because there's a superclass one. That top one called super, and the super is the bottom. That's kind of inverted. But you'll notice there it basically takes that environment hash, turns it into a request object, messes with, stuffs some junk into the hash, and then continues on its way. And it does this and calls super. And we have another thing. So the next thing is calls the next one. You'll notice here online, what is that? That very bottom one, it says app.call, so it's passing it down, right? Passing it down. So the next thing it does is it calls rack send file, and this sends static files. So if you read the description, it's like, all right, we're going to send some static files, and you'll see inside of send file, all we do is just send off to the next one in the stack. So the next one is action dispatch static. This one is for handling static content, and you can see a very similar pattern here. All we do is we're accessing some stuff in that env hash and then basically calling down the stack. And one thing I want you to notice about this is, so Ruby string literals are mutable, which means every time we evaluate them, they actually do a string allocation. So you'll see here when every time we're accessing this env hash, we're actually allocating strings. And down there where we do the hash assignment, we're actually allocating 2 strings because hashes will dupe it when you set. Anyway, then we go to this one, and then this one, this one, this one, this one, this one, and we keep going and going and going, and we keep going, and I think there was a web console one, we saw talk about that, and then we keep going and going, and we're still going, and this is more, we're going, oh man, it's still going, these are, okay, okay, there we go, okay, finally, we made it through all of them. Okay, stop. So we saw all of them, finally we get to the router, okay. We got to the router, we went through all of the middleware in the stack, and all those previous slides that you saw, those were actually summaries of each of the things in the stack. So if you really want to know what they were, I will post these slides later and you can take a look. But anyway, all right, we get to the router. Finally at the router, great. It's time to actually get down to business and do some work. So we have, remember, we were working with one application. Our application had one resource, and that resource is posts. We're building a blog, and the browser did get/users. So we went through that entire stack only for the router to go 404. So we did all that work, and then we do this. We were just mad. So I'm sitting there thinking, like, wow, we went through this entire stack all the way down to the router, and then boom, we blow up 404. So this is what I think of. I got to show you. I made a slide. And I did a lot of work on this slide, so I did a lot of work. And I don't know if I have sound. Do I? I hope I have sound on the next slide because I worked on this slide so much. Anyway, this is the stack. Now let's imagine that the stack was flipped upside down and turned into a mountain. This is what it would look like. Now let's imagine that we have a request coming in. The browser sends a request, and this is what happens. The browser, it comes along like this. Okay, and then there's I don't have any sound, so what is happening here is there's yodeling. It's going yodelay hee-hoo, yodelay hee-hoo. And he gets all the way to the top. He's going along through all these middlewares, and then finally hits the router, and then, oh. That took me forever to make. You should appreciate that slide. So thank you. Thank you. So there's actually sound that goes along with the slide, and I had to time the sound exactly perfect. So I was playing this slide over and over and over again, and my wife was like, "What are you doing?" And I was like, "I'm working." Anyway, I'm really sorry. We went through all of those middleware, and you can tell we're suffering from many problems, and one of the problems is it's just too long. Like, it's too long, okay? I have an extremely short attention span, and we have an extremely long amount of middleware. It's too long, and it's too boring. I want my code to be exciting. I don't want to go through all these layers of onions just to get down to the router so that I can see a 404. It really annoys me. The other problem is, like, why is the router buried so far? Why is that down at the bottom? It doesn't make sense. We knew all the way at the very top of the stack. We knew up there, way at the top, that the browser sent to get users. At that point, we know it's a 404. We know it doesn't route anywhere, so why do we have to go through all that stuff? So why are there so many? Why are there so many of these middleware also? Anyway, so thinking about that, let's go on and take a look at Rack API limitations. Like, I wanted to think about why exactly do we have all those middleware? All right, I think the reason that we have that giant stack is that today, Rack treats all middleware the same. We only have one API. There's only one thing that we can do. If you go through and look at each of these middleware, there's roughly a few different types. They're all doing some particular thing, and you can categorize these middleware into basically different types of middleware. Anyway, I think the problem is, we'll look at the different types of middleware in a minute, but I think the problem is that is the API itself. So if you see the API, like, again, this is our API. First off, we have an issue with the env hash. We can't change the type of this hash. The reason, or the type of this parameter, and the reason we can't do that is because you'll see there's 153 methods just on hash itself. There's no way that I can create an object that will pretend to be a hash well enough and not break everybody's applications. The other thing is that we can't change the keys. Think about that. If you have a hash that has some keys in it, how do you indicate to users that one of those is deprecated? You can't. You have to maintain that key forever. The other thing is, I mentioned this a little bit when we were looking at the middleware, is that it encourages allocations. You'll see there we've got this key that's actually allocating 2 strings every time we run this method. And I mean, this may not matter for one middleware, but if you look at the number of middleware that we have in Rails, it can actually make an impact. Also, apps are coupled to these key names. We have these key names hard-coded all over the place. If you look through the Rails source code today, you'll see that there's these hard-coded magic strings. And it's kind of weird to me because all of us as programmers, we know we don't want to hard-code magic strings everywhere, right? We don't want to hard-code magic values. But for some reason, when it comes to this web framework, we just throw that all out the window. We're like, you know what? Hash, whatever. Don't care. Magic strings, fine. Seems good. So that bothers me a lot. It's something I want to change. So I mentioned that hashes encourage allocations. Here we're allocating extra strings there. The other thing is the return value. If we take a look at the return value, here's the return value. Okay, we're going to return a 200. We have a hash of headers and then a body. Now again, we can't change the type. There's no way we can change the type. There's no way I can fake an array well enough. It's also coupled to the array layout. So what if one day I decided, you know what, I think that the status would be better if we put it at the end of the array. We can't do that. It's going to break everything. The other thing is that it makes streaming difficult. It's possible to do streaming. We looked at streaming with Node.js a little bit earlier. We can do streaming with Rack, but the way that you do it is you have to provide a promise for the body. So the body has to generate stuff. It has to respond to each and generate things. So we have to kind of invert our brains. Where with the Node.js part, we're saying, okay, I just want to write some data out to the socket. With rack, if you want to do streaming, you have to think, okay, every time each is called on this object, I need to return a different string to go along with that. So you have to kind of invert the way that you think. Now, also think about adding a header. Let's say I want to write a middleware that adds a header to the response. Okay, so here's my middleware. So I'm going to add an xcat middleware and middleware. It's a belt. So the way that we do that is we actually have to call down the chain, and then we get the headers back, and then we add our header. All right. So our object graph looks like this. We have this is a graph of the objects in memory. Our web server contains a reference to the middleware, and the middleware contains a reference to the application. Now, the way the data flow works is something like this. Our client, here's our client, our web server, and our middleware and application. So a request comes in, that goes to the web server calls the middleware returns back up, and you see there we add the new header in the middleware, and it gets returned back up the stack to the client, right? So everything worked, the header was added, and it was sent out to the client. Now, let's say we want to do streaming. Let's say in rack we actually have access to the I/O object in that end hash if you look carefully enough. So we're going to do streaming, and the way that we're going to do streaming is we're going to start writing data out to the client. So let's imagine what the data flow would be like if we do that. So again, same setup here. Now what happens is the client sends a request that goes to the web server, the middleware, the application, but then the application decides, hey, I want to start streaming to the client, so it immediately starts writing to this I/O object. Right? We have to flush all of the headers, flush the status, flush the headers, and then start writing to the I/O object. And you'll notice here on the left, we have communication via stack, and on the right, we have communication via I/O. So you could say today that if you look at the way the rack stack is set up, our response is coupled to the stack. The response is coupled to the full stack. But I'm a short stack developer. Anyway, so you'll notice here, back here, when we went through this entire client request and response cycle, you'll notice that return value our header did not get added because we actually had to skip that, right? Our response didn't go back up through the stack, so our response is actually coupled to the stack. All right, so what should we be doing? What do I think we should be doing? I personally like to steal things, as you saw earlier. So I want to steal from Node.js. I would love to steal from this. I would love it if we had a request and a response object, because we can do all of these things. We're no longer coupled to the stack. We have actual objects with small APIs. So we can say, I have this particular object that has a very small API. It only responds to a handful of methods. So if you want to implement your own, you can. I'd also like to add a server context for allocating request and response objects. And one thing I'd like to do is eliminate middleware. I think this is a very smart thing that they did with Node.js. You'll notice when you install Node, there is no such thing as middleware. It does not exist. You have to install something like Connect or some other framework for doing middleware. The middleware did not exist with Node, but it does with Rack. Now, I have a suggestion for middleware. This is just my suggestion. What I think we should have. If you look at all the middleware in Rails, we have basically 3 different types. We have event listeners, content filters, and content producers. So event listeners, for example, are things like we want to do something at the beginning, streams, multiple streams, and handles response pushes as well, so you can push out responses. So right there we say like, hey, if we have headers, if we receive a headers frame, we know that the request has been completed and it's time for us to send a response, and right there is our body. And I'm going to zoom in on that a little bit. You'll see right here, there's our frame receive event, so we get multiple frames in H2, and I can say, hey, is this a headers frame? Did I finish getting all the headers? You'll see there a lot of times the server deals with a stream ID, and this is what I was talking about earlier, is we have multiple requests and responses going over the same socket. And because of that, we need to differentiate them. We need some way to tell, which ones belong to which, and the way we do that is via a stream ID. So each stream will have a particular ID. And you can see there, like, I'm basing everything on that stream ID. So again, I don't really want you to read the code. This is just WebRick integration. Basically, this is the entire WebRick server integration here. The very bottom of that is actually, the bottom section of code is just generating an SSL certificate and actually starting up the server. That very top there is the entire integration. And what's really cool about this is I can tell, hey, is this H2 where that arrow is pointing? If it's not H2, I just call super and WebRick works perfectly. So we can use this server with Safari that doesn't support H2 or with Chrome that does. Down here is our response object. This is a normal WebRick response object. Actually, this bottom chunk of code, you could drop this into a normal WebRick server today and it would work exactly the same. The next thing here is our response object, and all I want you to do is notice that inherits from HTTP response. So it acts exactly the same way as a normal WebRick response. Request object does exactly the same thing here. This is that's all of the code to support it. And you can see here is a basic WebRick server running, and you can see there it doesn't have anything mounted on slash. We're serving up a 404 page over H2. So that's the entire thing over H2. All of WebRick just working. And I think it's really cool. You'll see the time there is 4 milliseconds. It served up 404 in 4 milliseconds. That made me happy. 4 milliseconds. 4 milliseconds. That's so fast. So here's an example of the actual Hello World one where you can see up there at the top it says Hi Mom. We're serving over H2. Again, 4 milliseconds. Very, very cool. Made me happy. I love fast stuff. So anyway, all right. So cool. We have this working. Great. We have an H2 server, WebRick H2 server, so we can actually run Rails on H2 now. Well, we have a web server that supports H2 and we can integrate with Rails. So the thing we need to do to integrate with Rails is add event handlers, the things that I was talking about earlier. And the way that this changes the code in Rails is we have something that looks like this. So this is wrapped lock before. Basically, this is a middleware that what it does is it takes out a mutex at the beginning of your request and then releases that mutex at the end of the request. So this is what the code looks like before. You don't need to read it. It's just, that is what it looks like. And then notice, after we go to a world where, imagine a world where we separate these types of middleware, where we admit that there are different types of middleware. In that world, this is what the code will look like. So you'll see it's much easier. Not only is it easier, but if we profile this code, before we were doing 3 allocations, now we've reduced that to 0 in the new method, or in the new middleware. Previously we had 8 method calls, now it's 2. We had 1 conditional, now we have 0. So not only does admitting that we have these different types of middleware simplify our code, but it also makes it more performant. Now unfortunately, this also meant that I had to go through all of Rails and convert everything that said call env to call request and response. Right? This isn't that great, noticing how many middlewares we had. Middlewares, I'm not sure what the plural is. And I speak English. That makes sense. Anyway, so we need to do a legacy conversion. I don't want to do this. You know, Matt's mentioned at the very beginning of the conference, I don't want to suffer from second system syndrome and make something that blows up for everybody. So what we need to do is come up with a way to be backwards compatible, and I think I've got a way to do that. Essentially what we'll do is wrap all of our env code. So this is what we're going to do in Rails, and what I recommend people do, though we can work around it. Essentially what we're doing in Rails is wrapping all env access with methods. So for example, when I see stuff like this in Rails, and if you want to contribute to Rails, go look through our code base for stuff that looks like this. Essentially, this is our old code. We're accessing that hash directly. What we do is change that to just access a method. And behind the scenes, that method actually just accesses the hash. Now, if I do all that stuff, convert all those things to method access, we actually get H2 support. And you'll see here, this is Rails running on H2. Be excited. This is the time. Thank you, yay, Rails on H2. Woo! If we have time at the end, these 3 bars down there kind of annoy me, and I'll talk about that a little later. But all this is done over one socket. So anyway, all right, we've been talking about H2. I showed you Rails running H2. I want to talk about some of the issues with H2, or I like to call them HTTP problem, or HTTP problem. And since everything is over SSL, they are HTTP problems. Sorry, I gotta take a laugh break. All right, so H2 is really nice. We get a bunch of speed benefits for this, but the thing is, header values still suck, right? H2 didn't do anything to solve header issues. I showed you earlier, all of our headers are lowercase. That's great. That's very nice. But, for example, when people do multi-part posts, or when you need to parse cookies, any of that type of stuff, none of that has changed. That's all exactly the same as it was in H1. Exactly the same. So none of that stuff is improved. The only thing that's really improved is basically over-the-wire communication. Another issue is that browsers are dumb. Like, browsers are not the smartest things right now, especially when it comes to H2. For example, can you push an asset twice? Like, what if I push the same asset twice? What happens? And the answer is you can actually push it twice, but the browser may or may not reject it. We don't know. It could reject that asset, or it could accept it. And the annoying thing is you don't want to push it twice, because that would just be a waste of bandwidth, right? What's interesting, though, is that, remember earlier we had one connection, which means that each browser has one context. So inside of our web server, we can actually take advantage of that and say, like, hey, I see that you've already pushed this. I see that you've already pushed this asset. We're not going to push it again. So we can track the pushed assets and only push new ones. Now, we don't necessarily want to be running WebRick in production, I don't think. But what we can do instead is, if you're using Nginx, which already supports H2, we can just put link headers in the response for Nginx, so Nginx can push those out. So you might be asking, why, Aaron, why are you doing this? Why are you looking at this stuff? The main reason I'm looking at H2 is essentially for asset push in dev. So the application that we're working on at work, which again you can go check out the GitHub page, has a lot of assets, and I noticed that as we're developing on it, you'll do a request and you'll see it's just pushing tons and tons of assets down to the client. And of course, none of these assets are compressed because we're doing this in development. And we could be saving tons of time if we were using H2, because we're sharing one connection and we can push them down in advance. Essentially, it would be like using all that asset compression, but we get that advantage in the development environment. So what I want to do is my basic plan is to say, well, we know about all these assets in development, or we know about all these assets in Rails because we provide things like the style sheet link tag. Every time you call style sheet link tag or your JavaScript tags, we know that you're serving up these assets, so we can automatically push those down. The other thing I'm investigating this for is especially things like writing rich client-side applications. Like, for example, with say you're writing an Ember application or a React application or whatever, you have a rich application on the client side. Typically what you have to do is you have to push down the initial JSON payload with that first request. Now, that's not very fun because it means that you can't cache that page completely. You have to put a dynamic blob of text in the middle. So what would be nice is if we can use asset pushes to push that JSON down along with the first request, then we can cache that HTML and get a responsive page. So there are the other various benefits, like the faster speed on development, or faster over-the-wire speed in development, but mainly those things are what I'm looking at. So my personal goal with this project is essentially to make a fast development experience. I want my development experience with Rails to be fast, even on large applications like the one that we're developing at work. So future work that I need to do, essentially we need to integrate push server with Rails. I showed you the graph earlier, and I said I was kind of annoyed. We had that request and then the three bars over on the right. The reason I was annoyed with that is because it's H2. Yes, I was serving Rails pages over H2, but I wasn't doing any pushes. So the client could have been downloading all of those assets in parallel with the very first request. We could have shaved maybe, I don't know, 20 milliseconds or so off of that response, but I don't have push integrated with Rails yet. The next thing I need to do is get all the tests passing. The hard part. And then backwards compatibility as well. So I've got some ideas for making all of this stuff backwards compatible, and my rough plan essentially is to release a Rack 2.0 along with Rails 5 that introduces a lot of these features but maintains backwards compatibility, and then eventually in the future release a Rack 3.0 that breaks everything, possibly. I don't know, that's way, way far out in the future and I'm not sure, essentially. So, conclusion, what I want you to take home from this today, we've looked at a whole bunch of stuff, a whole bunch of code. What I want you to take home from this is maybe, none of this stuff really matters because I'm working on all of it. You don't have to. Please come help me if you have time. I would appreciate it. But what I want you to take home for your day-to-day job, like when you have to go back to work on Monday, is Ruby's strength is OO. So Ruby is very, very strong with as an OO language, and we should be using that strength to our advantage. So we should be using the advantages that Ruby provides us, using objects instead of just passing around hashes. So that's all I have today. Thank you very much. I appreciate you having me. Thank you. I don't know do we have time for questions? Okay.
有没有人有任何的问题想要问 Aaron 的 ？Any questions?
Don't forget to vote for me.
Yes. Ricky, please.
Hi, Aaron. So something like Rack is like used by almost like most of the applications that runs Ruby on the web today. And so like when you're changing the API that's for something that's fundamental, like have you like, so I know you're already on the Rails core team, but have you like, has this sort of design been consulted with like sort of authors of say like Puma or Unicorn and Sinatra and such?
Yeah, so I've thank you for the question. Yeah. Yes, in fact, I am discussing with those people. I've been working with just recently started working with the Sinatra team on this. I've also been discussing it with Evan, who's the Puma developer. I've discussed it a little bit with the Unicorn author, but he doesn't seem to care about HTTP2. Though the way that I want to design this is such that the web servers will never have to change. So essentially all web servers, even with going to Rack 2, going to Rack 3, forever, they will never have to change their APIs. So essentially, web servers will always continue to work. It's mainly the framework side that needs most of the coordination.
Any more questions? 还有没有任何人有问题的，欢迎举手发问。Ricky.
Hello. Hi. Another question then. So like a lot of middlewares that are actually like executing on different logic of what we should do with the request and the response. So do you think like some of those logic, because since some of those logic are like don't actually affect one another, do you think there's benefits to parallelization there?
Probably yes. Yeah, we could definitely there would definitely be some benefits to parallelization there. The other thing is, I've noticed a lot of the middleware could essentially be methods that were just placed on a request object. Because essentially, like, most of that stuff, well, much of that stuff you may never need. Essentially, especially stuff like, if you notice all that stuff I scrolled through, one of the middlewares was actually like accessing or setting up the session, essentially. And if we just put that onto the request object, we could go through that entire stack, hit a 404, and then never set up the session, and it would be nice. So we could have the session lazily instantiated based on the methods that you call on the request object. So it's none of that work is done until you actually need it, as late as possible. So I didn't mention that in the slides, but I think that's another issue of the Rack middleware, is it forces you to do things possibly too early. But yeah, parallelization, definitely.
最后一个问题 ，one final question. Anybody?
plenty of stickers too, so if you want to ask me later.
如果有人想要他的宠物猫咪的贴纸的话，请找他。
Wow, live translation. Thank
Yes.
you.
Well, let's give a big round of applause for Aaron.
Thank you so much.
谢谢 Aaron 给我们的分享。那我们今天的议程呢，就到这边结束了。那我们谢谢所有来参加的会众，还有我们所有来。